Hello students. In the previous lessons, we have been building towards understanding vector diagrams and being able to interpret them. Today, I'd like to start off with a PHET interactive simulation. It's called vector addition, and you can go to that and play around with this also. You can also use this to help identify if you're doing some of your work correctly or not. We can go to Explore 2D. Now once we're in here, I'm just going to grab a vector, all right? And we'll have this one. This one's just going to be due north right here. And if we're looking at the values for this, I know that this would be like 15 meters and it would be towards the north. If this person were to turn and go due east now, so I put the second vector at the tip of the first, that's the tip to tail method. All right, we would calculate this where the first one we'd walk 15 meters north, and then this one right here, this would be 15 meters to the east. Now, if we did the math of this, we'd walk a total distance of 30 meters, but what would be the displacement? The displacement, well, what we can do is we can put in first what our angles would be, okay, for those values. I can put in the values for it and see how far each one of these vectors would be, the magnitude of it. Now, if we added them together, what do we end up with? Well, we end up with the resultant vector. Now, we would use the Pythagorean theorem. We'd have right here, we'd have c squared equals a squared plus b squared, and that's where they got the 21.2. And then we could use the SOHCAHTOA. We'd have our tangent theta equals opposite over adjacent to figure out what your internal angle of this would be. But what happens if we don't have a right triangle? Not everybody is going to walk due north and then go due east. What happens if this person were to walk at an angle like this? Okay, if this is our sample problem here, where the person walked due north 15 meters, but then they turned at if they turned at 26.6 degrees off of east and then walked another distance, what would their displacement be here? Well, you cannot use the Pythagorean theorem and you cannot use SOHCAHTOA using these two component vectors. All right, what you would have to use is some vector addition. We would need to get the x and y values for each one of these components. And then out of that, what we would do is we would form not two separate triangles, okay? Instead, what we would do is we would say, all right, this diagram right here, if I want this to figure out what the x and y components would be for this resultant vector right here, well, if I look at the y-axis first, I know that this blue, dark blue, or purple vector, that resultant, it goes up to this point, right? Well, part of that up movement was from this portion right here. And then what about the rest of it? We only got up to this height. What about this height right here? Where'd that height come from? It came from this vector's y value. All right. Now, in terms of the x-axis now, I know that I started right here, and my purple vector goes to about this length. What makes up that x value? Well, we get no x value from this guy here, but from this one, do you notice that we go from our starting point and then we go over right to here? Okay, so if we add up those values, and I'm going to do this, do you see here, now with this purple vector, do you see how we form a big triangle by adding up the y value from this and the y value from that? And then the x value, we add up the x value here. So we can use the x and y values for each of the component vectors, add them up, and we get a right triangle. All right, we're going to practice this on some of our problems for today, but we could even add in a third vector. Let's say that this person, they were to walk like this now. Do you see how when we're looking at the x values, we went up 15, we went up another 7, but then we came back 5, and then my value for the x value for the resultant vector would only be 17, because we'd have 15 plus 7 minus 5 gets you 17. And then for the x value for this resultant, I don't think anybody would disagree that if I walked here, walked here, walked here, that I would have a displacement from this point to that point. Well, where did that x distance come from? It came from here, and then it came from here. So if we add 14 and 15, we end up with 29, this value right here. All right, so I hope that is not confusing. And the reason why I pointed out the vector addition simulation is so that way you could jump in here and you could play around with some of the numbers. Maybe if you're a little insecure about doing some of the problems, you could use this simulation to help maybe not get the exact value, but see what the close value should be to your answers. What we'll turn over to now is the homework for tonight. The homework for tonight, or today in class, is going to be to solve for the resultant vector for these particular diagrams. Now, these are a little different because they are not given to you in the form of a right triangle, but you can get them into right triangles by adding up the x and y values for each of those components. All right, and that's what this over here is for, so that's something new. What you'll need to do is sketch out each of the diagrams and then fill in the material. This is labor intensive because in order to get one answer right here, you're going to have several problems to do ahead of time. But if you follow along with me, there's not going to be an issue. All right. To start off, let's just get this general idea of this diagram right here. If you and a friend were to kick a ball at the exact same time, your friend is kicking it to the upper right direction like this, and then you're kicking it to the left like that. Where will that ball actually go? We know that the ball is not going to move downwards. Both of you guys are kicking it towards the top portion of the paper here. So we know it's not going to go downwards. Is it going to go more this direction here? No, because your friend kicked it with a larger force. So I'm going to predict this one, that ball, and I'm just going to freehand sketch this. I'm going to say that this ball would follow a path something like, let's go a little bit longer than that. This is what I'm going to guess it's going to be. I'm going to guess it to be that. Now, where did I come up with this idea? I know that blue one, my resultant, my guess, has to be taller than what this guy is and what this one is, because if we're looking at this y value and this y value right here, added up, I know that those two y values has to equal, let's see how well I did. That's pretty close. They have to add up to be the height of my guess. All right. So with me reducing the amount of mumbo jumbo there, let's actually get to the solving of this thing. Let's start off with letter A. Letter A, we're going to break these up into the two different x and y values for each of these. This is my angle right here that's given to me. I see 55 degrees. I'm going to figure out what is the y value for that 8 meter per second. And I'm going to figure out what the x value is for that 8 meter per second. All right, so I know it's pointing to the upper left. So The upper part, we're going to try to figure that out. And then the left part, we're going to try to figure that out as well. To start off, if that is my angle, I'm going to label my diagram. I know that this is the opposite side. We know that this is the hypotenuse. And we know that this is the adjacent side right here. Right? If we have our angle, 55 degrees, and the 8 is the length of that vector, I know the angle and I know the hypotenuse, so I'm going to use sine and cosine to get these. So if you need to go back to the circle diagrams, then go ahead and do so. We'll start off with the x-axis first. Now the x-axis, this value right here, we're going to solve for that. So I'm going to put my area right here so that way we know which part we're looking at. If our x value, we have cosine for this. So we have cosine 55 equals the adjacent side. I don't know what that is, so I'm going to put A. And then we have the hypotenuse is 8. So on a calculator, we will have cosine 55. Make sure that you put it in parentheses. And then we have to multiply that by the 8. So we get a value for the x-axis, or I'm sorry, the y-axis of let's round it off, 4.6. Before you go any further, we figured out the y value. The y value is this guy right here. So let's put that number in, 4.6. The most common mistake that people make is they will get these two values flip-flopped. All right, and this is why I'm saying if you take your time and fill in the information as you go, you're going to reduce the errors that you make. Let's go to the next one. We're going to figure out the x value for this now. The x value, if I look at the trigonomic function that I'll have to use for it, it's going to be sine. So I have sine 55 degrees equals opposite over 8. All right, why 8? Because that's the hypotenuse. Opposite is this side. We put this into the calculator. We have sine 55, close it, times 8 equals 6.6. So that value we determined to be the x-axis. So that's 6.6. We'll jump over to the other side now for B. For B now, we want to get the x value for this one, and we need to get the y value for that one. All right, let's do the labeling of this first. If this is my angle, this would be the opposite side, this would be the adjacent side, and then the 10 would be the hypotenuse. We'll do the x-axis first here. The x-axis, if we have our math here, we have cosine of 40 degrees. Why cosine? Because I have the adjacent and I know the hypotenuse. We have adjacent divided by 10. So calculator, we'll have cosine 40, close it, times 10. That gets you 7.7 for this. And that will fit into the x-axis. So I have 7.7. We go to the next labeling. We'll have the y value now. So the y value, I'm running out of space. The y value, what we'll have here is that's going to be sine 40 degrees times, we'll go equals. We'll set it up just like we did the other ones. Opposite over 10. Calculator, we have sine 40, close it, times 10. That is 6.4. We'll put this into my chart, 6.4. Now what we're ready to do is to add up your values. All right. Before we add up the values, let's make sure that we have all of our information into the correct spots. See, I can check this, and I say the green value here matches up with the green value, and that's on the y-axis. That's pointing upwards, so that's on the y-axis, and since it's going up, that's a positive value. All right, the next one that we can check out, let's check out this yellow here. The yellow, all right, so that value matches up to 6.6, and right here, the yellow is on the x-axis, but what do we notice? We notice that it's pointing to the left. So what should your value be? Should it be positive? No, that should be a negative right here. All right, so be sure that you check your work, just like we're doing here, is if you just put the numbers in, sure, the 6.6 is correct, but unless you look at the diagram itself, you're not going to know that that should be a negative value. All right, let's check the other values to make sure they're okay. The light blue is on the x-axis. It matched up to 7.7. It's going to the right, so it's positive. It's all good. We have our purple here. That matches up, 6.3. It's going upwards, so that's positive. So that's all set. We're ready now to add these values up together. So these two values here, if we add them up, you get a value of 11. If we add these two values up here, what we end up with is 1.1. All right, these numbers, the 1.1 and the 11, what these represent would be the x and y values for your resultant vector. We'll have the 1.1 first. That's on the x-axis, so that means I'm going to come over 1.1, and then it's going to go up on the y-axis 11. So I'll draw this up to 11. All right. This value is supposed to represent my, and I didn't do a very good job at drawing out my 11, but you get the idea. It's not really drawing the scale. That blue line there represents the resultant where my line, my ball, would actually move towards. So we want to figure out what the magnitude of this guy is. I know two sides to my triangle, so I can use the Pythagorean theorem. C equals the square root of 1.1 squared plus 11 squared. All right. And we'll put this into the calculator now. Oops. Square root 1.1 squared plus 11 squared. That gets me 11.1. And we want to make sure that we put our unit of measurement on here. Now we need the angle. The angle, we just look at what the inside angle right here is. This side is the opposite side. This side is the adjacent side. So I can use tangent theta equals opposite divided by adjacent. I go to put that into the calculator. I want the inverse tangent of 11 divided by 1.1. Close it. That is an 84.3 degree. And I'm just going to put on here north of east direction. Now, I didn't do a good job at matching these up, but if we look at this value, doesn't it look like it goes up that way right here, just like we were guessing it to be? All right, so that's the first one. So let's move on to question 2. We have our two component vectors. So we'll start out with labeling the x and y values for each one of these. So for us to have the a vector, I have to come up on the y-axis and over on the x-axis. The angle is here, so that means that this side is the opposite side, and then this side is the adjacent side. If the 25 degrees is my angle, let's first solve for the x-axis. So the x-axis will have our numbers. We'll go with cosine 25 degrees. equals opposite. I don't know what that is. And then our hypotenuse, I didn't label this, shame on me. The hypotenuse will be 15. So we put this into the calculator. We go cosine 25, close it, times 15 equals 13.6. That 13.6 belongs on the y-axis. See, you can see I actually tried to put it on the x there and realized, it's on the y-axis. I have it highlighted, so I have to put it in the right spot. So 13.6. The second vector now, the one along this axis, we will have for this one, we're going to use sine for this. So we have sine 25 degrees equals opposite over hypotenuse. We have sine 25, close it, times 15 equals 6.3. 6.3. And I'm going to match that up. That was along the y-axis. So that is 6.3. Now, since both of those were up and to the right, we know that both of those are positive. We'll go to our next one. We need to figure out what the x value is for b and what the y value is for b. First off, let's get the x value. So the x value for this, I will have my sides. We have opposite, adjacent, and this time I'll label my hypotenuse. We'll start off with cosine of 10 degrees equals the adjacent divided by our hypotenuse of 8. And I just noticed I did this. This should be adjacent. That should be adjacent up here. Putting that into the calculator, we go cosine 10 times 8 is 7.9. Matching it up. It's along the x-axis, so I'm going to put it into the x-axis spot. 7.9, it's going to the right, so that's a positive value. Our next one, we have the y value now for this one. So the y value will have sine 10 degrees equals opposite over the 8 equals calculator. Sine 10, close it, times 8 equals, we have 1.4. So 1.4, matching it up, it's upwards, so that's the y-axis. So we have 1.4. Since it is going upwards, that means that we're going to have a positive value for it. We start adding these things together. We have 13.6 plus your 1.4 gets you a value of 15. We have 6.3 plus 7.9 gets you 14.2. These values are now going to be put over onto your resultant vector. We'll go over 14.2, and then we're going to go up 15. So my resultant vector for this is going to look something like that right here. To get your angle, you'd have to label up your sides. And then to get your magnitude, we would need to use the Pythagorean. We'll have c equals the square root of 15 squared plus 14.2 squared. Square root 15 squared plus 14.2 squared. We'd have a value of 20.7. What was our meter per second? And then for the other part, we would have tangent. We have tangent theta equals, we have 15 divided by 14.2. So inverse tangent, because we want the angle, 15 divided by 14.2. Close it up. So that would be 46.6 degrees. And I'm going to put north of east. So if we were to look at this vector right here, what that is saying is that we have, when we combine those two, it's going to go up and over to the right with a magnitude of 20.7 at an angle of 46.6 degrees. So that's the outcome. If we added these up together, that's what we're going to have. Let's go to question number 3. Question 3, I'll try to speed through this one a little bit quicker. If you need to slow down, by all means, just pause the video and rewind it. So our x and y values, the x value here, y value here, we need to figure out, and this is my angle for this component. Labeling it, we have opposite, we have adjacent, and you have hypotenuse. For the adjacent side, we are going to use cosine. So we'll have cosine of 40 degrees equals adjacent divided by 3. That will take care of our x value for this. We have the numbers now. We'll have cosine 40 times 3, 2.3 for this value. So 2.3. We'll go to the next one. We have the y value for this now. The y value for this, if we put in our numbers, we have sine 40 equals opposite over 3. We'll have sine 40, close it, times 3. We have 1.9. So 1.9 we'll put in. Before I move any further, if we're looking at those values, the gray was to the left, so that means that that is negative, and the y is down, so that means that that is negative. That's why it's nice to show your work. We go to the right-hand side now. The right-hand side, we need to figure out the x value for b and the y value for b. The x value for b, this one, we would need to use, after we label this, adjacent, opposite, hypotenuse, we need to use the cosine of 44 degrees equals adjacent divided by 7. All right, so we have cosine 44 times 7 equals, we have 5. Let's just leave it at 5. We'll round it off at that. We go to, that needs to be put into our x value here, right? X value, we said, was 5, and it's going to the right, so that's positive. We'll go, we have this one here. We have the y value now. The y value for this, we'll have sine 44 equals opposite over 7. We'll have sine 44, close it, times 7 equals, we have 4.9. So 4.9. Now that value, when we put it in here, what do we have to make sure that that 4.9 is? It's pointing downwards, so that has to be negative. Now we're ready to add these two values up. When we add those two values up, you come up with a 6.8. Now that is a negative value. Then we go over to the other side. When we add those two up together, you get a 2.7 for it. These two numbers that we see here, these two numbers represent the components that are going to make up your resultant vector. So we will go over on the x-axis a value of 2.7, and then we're going to go down a value of 6.8. We're going down because it has a negative on this, okay? Those components make up your resultant vector. We need to find out your angle, and we need to figure out what your magnitude is. Magnitude is pretty simple, Pythagorean theorem. C equals the square root of 2.7 squared plus 6.8 squared. In your calculator, we have square root 2.7 squared plus 6.8 squared gets you 7.3 meter per second. Oh, this is newtons, sorry. Newtons. And then we need our angle for this. If this is the opposite side and that's the adjacent side, then we can use tangent. So we have tangent theta equals 6.8 divided by 2.7. We need the inverse tangent of this because we're trying to find the angle. Inverse tangent, 6.8 divided by 2.7 equals 68.3 degrees, and that would be south of east. Now, that vector, I'll point this out again, when we're looking at this vector right here, that is a culmination of the two vectors from before, the A and the B. I know that it's going to go down further than either of those two because we're adding it up, but you're going to notice that since you have a larger value over here, then our resultant is going to point more towards that direction. We have the last one that I'm going to help you with, and then you're going to have to work on the other ones. So this one, to start off with letter A, that vector component, we're not going to have to do any math with this. All right, this one is just a thinking outright problem. If we're looking at that vector, what's your x value for that? Well, it's -8. It doesn't go upwards on the y-axis, so your y value is 0. That's an easy one to start with. All right, we go to the next one. You have the B. You have some x value with this and some y value with this. This is my angle, so this is the opposite side, adjacent side, hypotenuse. Solving for this, I'm going to use cosine 33 equals adjacent divided by 10. And then when I go to solve for the opposite side, I'll use sine 33 is opposite over 10. All right. We'll put these into the calculator now. We have cosine 33, close it, times 10. You get 8.4 for the x value, 8.4. It's going to the right, so that is positive. Next one, we have sine 33 times 10, equals 5.4. 5.4, but that's pointing downwards, so that has to be a negative value here. Now, when we add these up, when you add up these values right here, you end up with negative 5.4. And then for the x value, when we add these two numbers up, you end up with a 0.4. All right, and if we were going to predict what the outcome of this would be, we'd say it's something like, I don't know, something like right in here. Okay, if two people were kicking a ball, one person's kicking this way, one person's kicking that way, then the ball is going to go in between those two directions. So, sketching this out, we have a x value of 0.4, and then it looks like we did a poor job at putting the spot here in. The y value should be a negative 5.4. So your resultant, what we have to figure out is this guy. All right. My angle is here. I know that this side is going to be the opposite side. This side is the adjacent. All right, let's get our numbers. For your values now, the magnitude, you'd have the square root of 0.4 squared plus 5.4 squared. We'll go square root. We have 0.4 squared plus 5.4 squared equals 5.4. So 5, and you know what? We can't have it be the exact same thing. We have to go 5.41. You can't have the hypotenuse be the same length as the opposite side. You can't have that. So we'll have 5.41 meters, and then we need an angle for this. So we're going to use tangent theta equals 5.4 divided by 0.4. All right. So we go with inverse tangent. 5.4 divided by 0.4 equals at an 85.8 degree angle, and this would be south of east right here. So that would be your answer.